Nicolas Liochon is a global lead for Linea, which is a new zkEVM rollup by Consensys. Rollups play a crucial role in scaling Ethereum as they reduce computational load on the main network by processing transactions off-chain. The two prominent rollups currently available are ZK Rollups and Optimistic Rollups, and Linea is the latest ZK Rollup to launch. In our conversation, we will explore how Linea sets itself apart in the already highly competitive Ethereum Layer 2 landscape. But first, we'll begin our conversation with an introduction to Linea by Nicolas.
What we're launching right now is what we call Mainnet Alpha, and it comes after many years of research. So we started to work actually on Rollups 5 years ago as a part of our work in research for the Ethereum protocol. Back then, we were working on Ethereum 2 with the idea that we will be having proof of stake and scalability. And proof of stake was solved kind of, I would not say easily, but came faster. And we were there with how to scale. Multiple options were looked at, and at a point, Rollups were seen as the best solution for Ethereum scalability. So we started to work at this in basically 2019, saying, okay, hey, that's how we want to do it. We think it's the right solution. And more we were convinced that it was the right solution. At the beginning, Rollups were very specialized because we thought, okay, it's slow, it's complicated, so we need to have very specialized Rollups. So we started to work actually on payments only, then anonymous payments, this type of stuff. And then we said, okay, but let's try to do a zkEVM, which is let's try to be able to interpret the bytecode of the EVM, the native bytecode of the Ethereum protocol, and let's try to put that into a system of zero knowledge in order to use this to scale. And actually we saw it's possible. So that's great, and it's so great, so we need absolutely to do a business out of this. And that's how Linea was created.
What is it about Linea that's different from other zkEVMs or ZK Rollups?
Yeah, so if you speak about ZK Rollups without mentioning zkEVM, the key point for us, we are a zkEVM working at the bytecode level. So it means that we're interpreting the bytecode as it is compiled by existing compilers. So people using the existing tools, people developing today on Ethereum Layer 1 can use Linea directly. Without any change, or with more say very minor changes. It's a key point because it means that the knowledge that the developers have already, they know Solidity, they know other tools that compiles to the EVM, it's going to work outside of the box. They don't need to learn new languages, they don't need to learn new tools. When they want to audit their product, all the teams that can audit layer 1 code can audit layer 2 code. We won't have all the things that we learned on layer 1 and we discover new way to do things that we should not be doing. This is known already. That's the EVM. We know how to audit this. We know what is secure. We know what is not secure. So we're leveraging all this. So we're not the only one working at the bytecode level. And our view on this is it's actually very good, because it's a very important thing for decentralization. So the fact that other people are doing like us, working at the bytecode level, means that as an application, as a developer, you're not locked to Linea. If you think that we're not working well enough, if you think that the Linea does not evolve properly, okay, you can move somewhere else. You won't have to relearn everything. You won't have to change your code. You won't have to redo audits all over the place. You can basically migrate. So it's a key element of the centralization, not being locked in by something. We see it as a key point. It includes the fact that the EVM, it's not something that we define. It's defined by the Ethereum Foundation. And we're just following the specification done by others, like others people implementing this type of zkEVM are doing.
Would it be fair to say that what Linea does is it's a rollup, and just like simplifying it very much, rollups are layer 2 chains, which means that they take some of the processing and computation out of the layer 1 chain for Ethereum, does that outside of Ethereum, and then rolls up all these transactions and confirms it on the Ethereum chain. But it speeds things up because you don't need to be confirming every single transaction as they happen. You roll them up. And there's these two main technologies that do this right now. It's optimistic rollups and zero knowledge rollups, and then zero knowledge EVM rollups are using the same coding language as Ethereum itself, to allow developers to build on these rollups. So that allows it as much flexibility as Ethereum does for developers to build on these chains. Is that kind of a good summary?
It's absolutely correct.
Awesome. Between ZK Rollups and optimistic rollups, why did you decide to go with ZK?
So the ZK1 is the most trustless solution. All the knowledge is on the layer 1, because we put on the layer 1 the way to verify that a state change is correct. And if the layer 1 says that the state change is correct, then we're done. And that's basically simply about this. The fact that everything is there on the layer 1 for everybody to see, and anyone can verify the change, that's the most secured way of doing things. So that's why we went for this solution.
Zero knowledge rollups allow for anyone to verify on-chain each transaction, and optimistic rollups don't? So
the main idea of the ZK Rollup is someone is going to create a batch of transactions, a sequence of transactions. That's why we call it the sequencer. And it's going to say, okay, for this sequence of transactions, I'm going to change from this state to this state. There will be a change of state. And this change of state can be sent to the layer 1. And the layer 1 will do two things. The layer 1 will verify that the change of state is correct, using a proof for this, verifying a proof, and will store all the data conducting from this state to this other, so anyone can recreate the states. And the fact that once it has been proven, you know that it's valid, means that there's implicitly a huge simplicity in how you use it. It's there. I don't have to think about maybe there will be a fraud in the future. Can I be sure that someone is going to create a fraud proof if someone is not available? What can happen? You don't have all this. It's all on the layer 1. It's finished. That's the main idea of this.
Okay, and instead, optimistic rollups don't do this?
Optimistic rollup, you're going to update the state on the layer 1, but you rely on this idea that maybe the state is not valid, maybe the change is not valid, so you expect that someone will detect that the change is not valid and will send a proof that the change is not valid. It means that there's a period of time, usually 1 week, where, well, we don't know. You don't know if the state is fine or not. You expect that if the state is not correct, someone will show up and will say, hey, this is not correct. But you need to wait 1 week, and you need to think about all the edge cases, which is what if nobody appears, what if there's a side corner case, edge cases, whatever. So incentivization to not doing a fraud, all this is something that disappears totally with the ZK Rollup.
Got it. Okay. In terms of usability, I think one of the main issues for rollups has been the delays in withdrawing and getting funds back on Ethereum or to the rollup. How does Linea work in that sense?
So it's like all ZK rollups. Once the proof is written on the layer 1, then, as we know that the state is correct, we can transfer the funds.
Okay, and how long does that take?
So that's an interesting question. Ultimately, it's very fast. Question of minutes. In practice, we're still in an alpha release, so we did put a delay on it in order to be sure that nothing bad is happening. So today it's configured at 8 hours, but this is something that is a part of the alpha release, the training wheels that we put to secure the system, and it's not something that will last.
Got it. Okay. And speaking about the alpha release, would be great to get some of the results and metrics that you've seen in the test phase you know, like the whole point of these rollups is to allow Ethereum to scale. So yeah, like what speed times, how many transactions per second are you seeing so far?
Yes, so it's a very interesting question. So we had on our testnet, so in around 6 months, and we started in January where we permissioned testnet, so actually 300 people were allowed to join, so it was very successful, but it was 300,000 people. And then in end of March, it became permissionless, so anyone could participate, and we saw a huge increase of adoption immediately. And at the end, we have today 47 million of transactions executed on our testnet with 5.5 million different addresses. So that's what we got, which is absolutely huge. A key point is, one of the differences that you see on the layer 2 and on the layer 1 is you have transactions that are usually more expensive in terms of gas. So the way we configured our system for the testnet is with the capacity double of Ethereum Mainnet. So we add 30 million gas per block every 12 seconds. The main idea of this is we're writing the data on Gurley, and Gurley is a test network, so if we write too much data, nobody else than us can actually use Gurley, and it's a test network a little bit shared, so we can't go crazy that much, okay? So that's a limitation. I will come back a little bit on that later. But this point that on layer 2 you have transactions with more gas, it's something that is very, very interesting for many use cases. A lot of people are limiting either the functionalities, either the safety of the system because they want the transactions to be very cheap. But as on the layer 2 we are much cheaper than on the layer 1, many things that are too expensive for the layer 1 becomes a non-issue in the layer 2. So that's one point. Another point that is interesting, and we mentioned how the rollups were working. When you have a rollup, you write the data on the layer 1, which means that if you have a lot of operations, you're going to use the layer 1 a lot. So you will use it much less than if you are doing the operation of the layer 1. That's why we are basically 15 to 25 times less expensive than the layer 1, but it's 25. Basically, you can, it's kind of maximum scalability that you can get. However, that's where the layer 2 and the layer 1 are working together. There is a lot of work happening in the layer 1 around data sharding, the EIP 4844, and all this will make the rollups much more efficient. And the technology that is used by the layer 1 is simple enough that the layer 1 should be able to scale all the time. So we will always have this story of, okay, we're a little bit limited even in the rollup by the layer 1, but the layer 1 is going to improve, and then the rollup will be fine, there will be more use cases, the layer 1 will improve again, and so on. So we'll have this endless story.
Okay, so you said 5.5 million addresses and 47 million transactions. And in terms of gas, you mentioned that rollups are somewhat limited by Ethereum Layer 1 in that the maximum reduction is between 20-25 times.
Yeah, around 20, yeah, exactly. Yeah, right now, and it's quite key to know that the EIP 4844 will change this in the next months, and that layer 1 has many opportunities to do even better. So it's really something that is going to have a huge potential for long-term improvements, and the limits are not known yet. We're at this stage.
This is EIP 1444, you said?
4844.
4844, sorry. And can you remind me what this EIP was about? Like, what will it unlock for layer 2s?
What it unlocks is the capacity to have much more data returned by the layer 1. And it's quite important because a way to kind of work around this layer 1 cost, what we call the data availability, is to put the data somewhere else. And when you do this, you have a dependency on the layer 1 and on this somewhere else. And your system is as secure as the least secured element, so you're playing games. So the fact that the layer 1 can improve, it's a huge benefit for the rollups and for the global security of the system. So that's why I'm pushing for this.
Very interesting. And you said that right now the level of improvement that EIP 4844 could bring is still unknown?
That's the limits that are unknown. Yes, because as it's basically what you're requiring with this new architecture, and it's really an evolution of Ethereum that we saw with all this work happening on Ethereum 2, the modularity of the system, is the main idea is we put the execution on the layer 2, and the layer 1 becomes a consensus and data layer. And being a data layer is something much simpler than being an execution layer, and it allows the data layer to scale. So it means you want to scale reasonably, you don't want to go too crazy immediately if you don't have the needs, but you have a lot of potential. So, oh, there's more use cases, let's add some data, and that's what the layer 1 will be doing.
In terms of the focus for Linea, you said that before you had started to work on payment-specific rollups, and then you decided to go in this direction that's kind of more generalized. But still, are you having a specific focus on different areas of Web3? Say, will you hope that more DeFi applications are built on Linea, or is it NFTs, or are you just going after any and all use cases?
So we think that it's quite important to be very generic. And if you try to say, okay, this is DeFi, this is gaming, this is NFT, you're missing some opportunities to have links, actually. So you can perfectly imagine, NFT, they have some value. So there's a part of the DeFi ecosystem. You've got NFT in the games. So there are links between this. You can go crazy. You can imagine that you can do a flash loan to get an NFT that you will do in a game, that you will use in a game, and that's it, you will pay back in a single transaction. So there's a lot of things that you can do, and we don't know everything. Like the flash loans, for example, from the fact that you can loan something just for a single transaction and use it with crazy amounts is something that was technically possible in 2015 from the very beginning of Ethereum, but nobody has thought about it. And if we allow multiple use cases to be there in a single rollup with huge scalability and performances capacity, I'm pretty sure that people will find ways to do some strange interactions that we're not thinking about right now, but they will actually make a lot of sense in the future, like flash loans today. We will get with some stuff. So it's really important for us to be able to have all type of use cases and all type of application instead of being very specialized.
Parcel, the decentralized real estate trading platform, is making it easier to get exposure to global real estate. Through city indices, you can trade the price change of popular US cities and easily access over 5 million properties with just a few clicks. With leverage up to 10x, you can go long or short and begin trading real estate in ways you never have before. Join today to start building a diversified real estate portfolio. We've mentioned here that there are many other rollups and layer 2 solutions being built. What's your vision, or how do you think these chains will interact in the future, if at all? Or do you think there will be one that has concentrated most of the volume and users, or do you think there will be a lot of interaction between many of these chains?
Yeah, so there's a perfect future that is a little bit difficult to get. That is called the multi-prover. And for this, I need to explain a little bit how we do the proof. Basically, to do a proof, you need to use very advanced cryptography. Basically, most of the time, that is less than 10 years old. And cryptographers, usually, when it's less than 25 years old, they think it's a little bit dangerous. So we're using very advanced technology, and it brings a risk. That's one point. And I think we need to be very transparent. Okay, it's very advanced. Maybe it will be broken later, we don't know. The subcomponents that we're using advanced hash functions that are a technical component that is absolutely key. It's something that is a little bit brittle. And it's not only this, like we're implementing the EVM, so it's not something that is final. It's not something that we're not going to touch it. And again, a common approach in cryptography is you do this, And if nobody touches for 10 years and uses it, but it does not have to be modified, then you can trust it a little. But here, the EVM standard is going to change. Many things are going to change. So not only we're using advanced tools, but we're using advanced tools with moving targets, and we're changing things. And okay, you can say, look, I've done audits, look, trust me. You can say all this. But there's a perfect cooperation scenario, which was actually proposed by Vitalik, which was saying, hey, actually all the zkEVMs are using very different technologies, which is good because the probability that all these technologies break at the same time is very low. And for a single rollup, instead of having a single rollup, a single zero-knowledge technology, we could have a single rollup building on multiple zero-knowledge technology. So when we want to change the state of a rollup, instead of having one proof, we come with multiple proofs, one per technology, and we say, oh, we have 4 provers with different technologies, and if 3 proofs are valid, then we can consider that the state, the update is valid, and we can do it. And this way, if you don't have an issue with 3 provers out of 4, you're comfortable that the update is valid. And this is a very interesting cooperation point because we're still motivated to invest in different technologies, but we're interested as well to cooperate in order to make the global system very secure. And it's very similar to what you have at the layer 1 today. In the layer 1, the Ethereum Foundation pays a lot of attention of having multiple implementations of the layer 1 protocol, and they try to have all these implementations with something like between 20 to 40% each, so they don't have too much importance. And that's exactly a kind of perfect future for the EVM, for the zkEVM, which is, yeah, we have multiple implementations and we're cooperating in order to allow more transactions, in order to make the system much more secure instead of hoping that there are no issues in the technology that we're using.
That's really interesting. Okay, so would it be that in this future, all the zkEVMs will work similar to how Ethereum implementation work? Like there's like different Ethereum clients, but they are all confirming the same transactions. They're all part of the same network. So in this future for zkEVMs that you're seeing, it would be the same. Like all zkEVMs would be part of the same network, which means that they would have to work with multiple proofs. Like they would all have to prove the same chains, like the same transactions. They like basically have the same database of transactions that they all agree on. And that means that applications built on one will also be useful on others. Like what would the consequences for users be in that future?
From this technology, you can do 2 things. You have actually 3 options. One is you continue to have competing networks, but they reuse the technologies of others. So you still have independent networks, but they are more secure because they cooperate in order to implement exactly the same standards at the same time, so we can have this multi-prover approach. That's one future. Another future is, say, we can have a single network. Why not? It's possible as well. And another one is, but now that we have basically a standard defined ultimately by the Ethereum Foundation, and we have multiple implementation, we can push this technology to the layer 1 to facilitate the scalability of the layer 1 natively as well. So all this is possible. We will see.
Okay, but in essence, what you think would be better is for all the zkEVMs to work together rather than compete.
So competition is very good in terms of performances. I think it's very important, and it makes the system much better. Like the way I see it, even if we're using different technologies, all these technologies are new, and there's a lot of improvement for performances in terms of speed, in terms of cost everywhere. And it's always the same thing. If you're alone and you say, oh, I'm 20 times faster than the layer 1 and there's no competition, well, just let's stop there. I mean, it's incredible already. But if you have people saying, oh yeah, but I can do 20 times faster, 25, 30 times faster, then you're going to push a little bit the envelope, And that's, I think what's going to happen is the others are progressing and the competition to be the fastest will make the system much better. Because people like to be the first, and that's pretty good. However, I think we can say, yes, that's a useful competition, but there's as well a lot of potential for cooperation, which is now that we're basically as fast as the others because we're running one after each other. Well, we can as well cooperate, not only on the speed, but on the global security of the system.
I want to get more details on the level of decentralization for Linea. Obviously, this is a really important point when doing anything on blockchains. There's different points that people will look at when using a layer 2. One is just the number of validators, the number of nodes involved in the network. The other one is a sequencer. So if you could go down kind of the different points for Linea on these issues.
Exactly. So I think all the rollups have exactly the same story, which is you start with something that is centralized, and then you decentralize it. And why centralization at the beginning is because of the complexity of the proof system, because of the complexity of the technology. At the very beginning, you want to say, okay, yes, in theory, anyone can send a proof, and if the proof is valid, there's nothing to think about. And there's, okay, yeah, but maybe there's a security issue in the proof, and we're not totally sure, so what do we do? And the way it is solved is to say, hey, actually, no, at the beginning, not everybody can send a proof. It's controlled by people that are known, like basically Consensys in our case. And there's a kind of trust which is involved, which is, okay, I trust that Consensys will not go too crazy. So there is a proof. And there's a security, which is, we can't have too many people updating the system. And it's obviously not acceptable, basically as simple as this, but it allows to have a first deliverable, which is, look, there's this proof working, we've got this scalability performance improvements, there's a lot of things. So it's a multiple step thing. And from this, what you want to minimize the trust and maximize the decentralization, which is very correlated and not fully correlated. So the point is, thanks to the proof, once the proof system is, I would say, proven enough, and maybe we'll need these multi-provers at a point, you can say, okay, you can trust in the proof, but given the complexity to produce the proof, it's still limited to a set of factors. And what you want to get from there is, okay, actually the proof is, not only the proof is stable, but actually many people can participate in the proof generation. You don't need a crazy amount of resources. That's a first step. And the second step is, and as well, it's not only when we're deciding to create this sequence of transactions, anyone can participate. Anyone can create a sequence that will be sent to a prover, and the prover will send this to the layer 1. So that's a path that we need to take. Today we are in this situation where there's this little trust that please trust us on this. But clearly decentralization is the next thing that we want to do because we need to remove this trust. So we've got a roadmap on this. We want to show that the proof system is sound. So we've got a very long specification of it. There will be a work on formal proof of it. There's a lot of work there. There will be a work as well on having everything open source so anyone can check. And then there will be a work on allowing everybody to participate with progressive steps in control. That's how it's going to work.
What's the timeline for these phases?
It's in quarters. It's a technical thing, so we need to spend the time that we need to spend on this. There's no doubt on that. That will be a driver for us. But we don't want to deliver something in 2029. That's not doable. So we will be much more aggressive on this.
When you open up the network for anyone to be able to participate in validating the proofs, what would the incentive be for other participants?
I don't understand your question.
I mean,
I'm joking. I don't understand it. It's a very good question, but it will come exactly with a decentralization. I don't have the answer yet.
Okay, yeah. All right, and then about your launch launch and plans to grow the ecosystem. I read about an ecosystem investment alliance. If you can explain what this is about.
Yeah, sure. So globally, of course, I mean, Ethereum is about builders, and the question for you is how you're going to facilitate the life of the builders on your system. So we think first by having a zkEVM, so we can reuse all this knowledge is the first thing. Something else that we've done as well as a part of a testnet is the work on the Quest. So we created a program where people could actually try the applications, all the dApps that were installed on Linea, as a way to maximize the link between users and apps, okay? Because it's something to be deployed on Linea, but okay, or zkEVM, how are going to be used? And we really want to maximize this. So it's something that we really worked on is, okay, how can we incentivize people to try all the apps that are around? So we had this system of Quest, and apps were crazily used. I mean, that was incredibly successful. And another thing, I mean, we're in a market where money is expensive. So how can we facilitate the contacts? So the idea of this fund is, this alliance is people building on Linea will be put in touch with people well known in the Linea ecosystem. So investors will understand exactly what those builders want to do. They will be able to see the advantage immediately. It will be much more efficient. And there will be as well synergies between this, which is actually the last part in terms of how to make builders successful. What we want as well is to maximize the possibilities of cooperation. I mentioned this example of a flash loan between NFT and game, which is, okay, maybe a dream today. But if we maximize the cooperation between builders, we may have application being built with the idea of reusing features from others. So that's what we want to do. So there will be a lot of work around maximizing cooperation on Linea. That's an important value for us.
Okay, so when you say that you're connecting builders with investors, are you working with external funds in crypto funds, or what investors are participating?
There's a long list, so I don't want to pick up some of them. That's good for relationships. It's better to, but there's a whole list available on Linea website already, and projects can apply immediately. There's a button, big button somewhere saying, "Oh, apply for funds." I think it's as simple as this, and they can describe what they do and how they want to get in touch with investors.
Do you have an existing ecosystem of dApps already building on Linea? And if you can kind of share a bit of the earliest dApps you're seeing?
Again, I don't want to give names because that's for cooperation. It's always better. But yes, we've got more than 100 applications installed on Linea today. So it's already big, and it's going to be much bigger in the near future. There's all types of dApps, oriented DeFi, oriented gaming, oriented NFT, all this, I think. As we said, it's quite key to have all this type of applications.
Arch is a crypto asset management platform that helps you maximize returns with diversified and gas-efficient investment strategies. Chasing yield doesn't pay off. Instead, the Arch Token Classification Standard, or ATCS, maps and classifies crypto assets to give you the best of Web3 in 7 products grouped by 3 categories: yield-bearing, index style, and risk-adjusted portfolios. Learn more at the link on the description. And about yourself, we've done all this conversation, and all I know about you is that you're leading Linea. But I'd love to learn more about kind of your background and how you came to be where you are today.
Yes, so my background is on distributed systems. I worked on distributed systems forever. I worked a lot on distributed databases in the past. I arrived at Consensys to work on the research for Ethereum 2. That's how I joined this space, and that's why basically all this story around how can we do scalability, or not this, not this, not this. Rollups is great. And so I led the research team of Consensys for a while, and this team was working on many different things. We were working on formal verification tools. How can you prove that something does what it says it does, both for the Ethereum protocol and for smart contracts. We worked on cryptography, which is obviously very useful when you want to do rollups. We worked a lot on the Ethereum protocol itself, its proof of stake, and the merge. The team who was working on the merge at Consensys was working in R&D, and the scalability that led to Rollup. And it's important for us because, again, there's this path. That's the fact as well when I'm saying, okay, we want to do a formal proof of our zkEVM. That's all those links that we're using. When we say, we're going to decentralize the rollup, that as well will be done with a team in R&D that we are working on the Ethereum protocol. All this will be leveraged, and that's how we will have a lot of, I would say, synergies and maximizing as well. Again, cooperation maybe between layer 1, layer 2, because we have this deep understanding.
About kind of the longer term vision for Linea and layer 2s more broadly, where would you like to see it go? Like what would the ideal outcome be for Linea, say 10 years from now?
Something that is interesting to mention, I would say more short term, is in terms of performances, there's a lot of work on the layer 1, and I mentioned, they need to be able to send more data. There's a lot of work, and we spoke about the competition between all the layer 2s around basically the prover, my prover is faster than yours, this type of story. I think we should think as well about the importance of a client, because if you want to execute a lot of transactions, well, you need to execute them quickly. It's not only generating the proof quickly, you need to execute them quickly. So there's a kind of, when I joined actually Ethereum 6 years ago, everybody was competing on the Consensys protocol, saying, my Consensys protocol is faster than everything else, and I will create a blockchain that will be 10 times faster than Ethereum. And it has not happened. It does not happen. Why? Because at the end of the day, executing the transaction is expensive, and you can do the consensus as fast as you want. If you're not fast enough on the execution itself, which is a very computer science thing, there's no cryptography, there's no fancy stuff, just executing the transaction. And it's already very complicated, actually. And so it's something that is going to be a challenge, I think, more than people anticipate for the next year. We do have at Consensys a team implementing a client, Bezu. So obviously that's something that is quite useful, and that will be quite important. So it's really, I would say, a short-term thing. And globally, and I mentioned this stuff which is basically 6 years old, and that's exactly this. 6 years ago, people were saying, yes, scalability thanks to Consensys, and I think that we now have the solution. So my point of view on this is, we still have some work to do. We need to improve as clients. We need to do this faster proof. But it's a problem that is about to be solved, which means that now people can basically leverage the fact that they can have many, many more transactions. There won't be spikes of activities like in the past. Transaction will be very cheap. And it opens many use cases. And I don't even know what will be those use cases. Again, generic rollups is useful because if you speak NFT and so on, but maybe there will be new ideas. So that's what I see is we're going to build a tool that others will be able to use to do things that I don't know yet what it will be, but I'm happy to see what will happen, what will be happening.
Interesting. What you were saying that before, 6 years ago, the discussion was around how to scale blockchains at the consensus level, which you think is very hard to do. So the solution appears to be that the way to scale blockchains is not at the consensus level, but on layer 2s using rollups. So this is what you mean that the problem has already been solved? Like to you, this is kind of the end state for scalability. Even if there's a lot of work to do on the layer 2 front and improve different things to make them even faster and more usable and so on, but to you, is it clear that ZK Rollups are the solution for Ethereum scalability?
Yes, for two reasons. So the first reason is the big issue that we had in the past when people, for example, were thinking that consensus protocols were the solution is on a blockchain, if you don't have ZK Rollups, to verify the execution, you need to re-execute the transactions. And if you have thousands of nodes participating in the blockchain, which that's what you want for security reasons and decentralization, it means that all those thousands of nodes will be executing the same transactions to verify that it's correct and that the miner is not lying. So that's why you're limited. I mean, you need all type of nodes all over the place to execute all those transactions. So when you already do 50 TPS, it's already crazy at this level. And that's why consensus was the wrong solution, because the problem was not having the consensus. The problem was just executing all these transactions on thousands of nodes. And the way Rollup solve this is to say, hey, we're going to decorrelate the fact that you verify the execution and the fact that we execute. Executing remains expensive, but it will be done by the sequencers, who can be high-end machines. And these high-end machines can, by definition, execute much more transactions. But it means it's still fully decentralized, because as a node, you will receive the data, but instead of having to re-execute all these transactions to verify, you will just, hey, give me the proof, I'm just going to check the proof. And checking the proof is a few milliseconds, whatever the number of transactions. And that solves this issue of I don't trust, but the only way to verify is to do everything myself. Here, you don't have to do everything yourself. You just have to verify the proof. That's why it's an incredibly good solution for scalability.
And what do you think is missing in the rollup space?
Decentralization. I think you ask a question, it was a very good question. So we're going to get there. That's the work that remains to be done.
Okay. But in terms of having all the pieces that you need for mainstream adoption, like getting rollups to be as fast as they can, to have the user experience be as good as it should be, in terms of that, like, what do you think is missing?
The zkEVM, it's about having the same user experience as on the layer 1. So if you're happy with the layer 1, you will get it on the layer 2 as well. That's the key advantage. And of course, we actually have some issues with the layer 1 today. The biggest one, in my opinion, is all the complexity of managing your accounts. We're saying to people, hey, you're going to manage your account yourself, and if you lose it, so you lost your funds. Oh, bad luck. There's a lot of complexity, which is, okay, every time you want to sign something, you need to use your account, and if you want to send the equivalent of $10 or the equivalent of $20,000, it's the same operation. Or you need to get into very complicated stuff. That's an issue. So to me, what we allow with Rollups is, because we're lowering the gas price, a lot of solutions around account abstractions become possible. And this is not something that is directly at the rollup level. Like it's something that the rollup enables. You could do that at the layer 1 level, but it's just incredibly expensive. While account abstraction at the layer 2 level is something you don't care. It's so cheap that you don't care. And that's why we have actually more gas used in the layer 2, is because people start to use this type of technologies. And it changes totally the user experience. So first, in terms of safety, you can, with account abstraction, manage differently different types of phones without having 20 different accounts. You can potentially sign with your phone for small amounts. All this becomes possible. You can manage account recovery in a simple way without having to add 10 layers. You can as well have applications that will pay for the users because it's a part of account abstraction. So all this becomes possible. And I'm not going to say that it's a rollup thing. It's something that is possible thanks to rollup. But it's something clearly for us at Linea, account abstraction, we're very strong believers of the difference it makes, as it really creates a much safer environment for users and a much more easier to use for developers as well, as the users don't have to pay for transactions.
In the past bull run, the gas cost and kind of the congestion of Ethereum was a big issue that I think kept a lot of new users from coming to Ethereum. Do you think that Rollups will be able to solve that in the next bull run?
Yes, with the layer 1. It's a cooperation game again. We need the Rollups to do their work, and we need the layer 1 to allow to write more data. Okay, so it's happening. I mean, I'm not asking or complaining. It's really like it's arriving. The EIP 4844 is planned for end of the year. So it's a cooperation. Like we really need this layer 1 to do things, but with the layer 1 adding more data availability and the Rollups adding more execution capability, yes, the bull run will be a bull run.
Will be smoother.
Will be a bull run.
Will be a good... Awesome. All right. Super interesting conversation, Nicolas. Thank you so much for joining me. If our listeners want to start experimenting with Linea, where should they go?
They should go on linea.build. They will have all the information there. .build, yeah. The testnet is there, and we can play with all the applications. This week, the mainnet is for dApps who are setting up everything, and it will be open next week for everybody to play with everything on mainnet. So the two systems are available. They can play right on testnet. Partners can install on Linea immediately, and they can call us, builders can call us to install their applications. And next week, everybody will be able to use it.
Awesome. So today is July 11th. So next week at ETHCC, everyone will be able to start using Linea.
At ETHCC.
Okay, very cool. All right, Nicolas, thanks again for your time and for the chat. Super interesting insights and viewpoints on layer 2s and scalability and zkEVM. So I really appreciate it. And thanks again.
Thanks a lot.